alaikum wa rahmatullahi wa barakatuh. Today, transpose of a matrix. Transpose of a matrix means interchange rows and columns. Okay? Or we can say transpose of the matrix means rows become columns and the columns become rows. In this matrix, 3, 4 is the first row. In the second matrix, 3, 4 became the first column. Okay? 2, 1, the second row became the second column. So this transpose, we can denote it by T. T, it means transpose. Transpose is interchange rows and columns. Okay? Look at this example. 2 by 3, the first matrix, in order 2 by 3. To transpose this matrix, it converted to 3 by 2. Okay? Because the rows become columns and the columns become rows. So the order 2 by 3 converted to 3 by 2. Example. The matrix A 1, 3, 4, 2, 3, 2, find AT. So we can write AT equals the first row 1, 3, 4, 1, 3, 4 became the first column, and the second 2, 3, 2. Okay, now we found the transpose of this matrix. After that, symmetric matrix and skew matrix. Symmetric matrix means this matrix which it equal its transpose. So A T equal A, such as this matrix 1, 1, negative 1, 1, 2, 0, negative 1, 0, 5. If we found the transpose of this matrix AT equal the first row 1, 1, negative 1 became the first column 1, 1, negative 1. The second 1, 2, 0, the second 1, 2, 0 became 1, 2, 0, and the third negative 1, 0, and the 5. Pay attention. Now the transpose of this matrix is itself the same origin matrix. So in this case, we say this matrix is symmetric matrix. But secure the matrix, secure symmetric, it means AT equal negative A. AT equal negative A. So when we find the AT or the second matrix, the first row 0, 1, negative 2, negative 1, 0, 3, 2, negative 3, 0. Compare between the two matrices. So each element is, or each element became the additive inverse of the origin element. 1 became negative 1, negative 2 became 2, 3 became negative 3, and so on. Okay, so we can say AT equal negative A. This matrix is called skew symmetric matrix. Okay, we can say another thing. In the symmetric matrix, these numbers or this elements is called principal diagonal. Principal diagonal. So we can note that the elements are symmetric about the principal diagonal. It means here 1 and here 1, here -1 and here -1, here 0 and here 0. So the elements are symmetric around the principal diagonal. But in the skew symmetric, the principal diagonal is 0, 0, 0, and the numbers, oh, the elements 1, -1, symmetric by inverse sign. 1, -1, -2, 2, 3, -3. Okay, so in this case it is called skew matrix. Example: if the matrix 2x5, 3, 6y, 5, -4, and 0 is symmetric, find x and y. Okay, this matrix is symmetric, so the elements symmetric about the principal diagonal. So x equal 3. We can write x equal 3, and y equals -4. Y equal -4. Okay, we can find x and y by find its transpose and equality of the origin matrix and its transpose. Okay, now we have finished this video. Assalamu alaikum wa rahmatullahi wa barakatuh.